Here is the response to the question number 16. The 6 sides of the solid shown below are 8 units long. A and B are the midpoints of edges QS, QS and RP. So A and B are the midpoint of these two sides of this solid. Midpoint of QS is A, midpoint of PR is B. Now before I start my explanation, I would like you to see the three-dimensional figure. I can rotate this figure to have a better view. You can see this is a three-dimensional. I can move it vertically as well as I can move horizontally. So this is a 3D. You have to understand how this point A and B are connected. So this is point A and B is connected to the opposite side. Now in order to find the solution, I will use couple additional diagrams to make it easy for you to understand the solution. So first thing, I'm going to draw a line segment between Q and B, which is on the rear face of this 3D. The face is PQR. So the first thing, I'm going to draw a line on the rear face of this solid and I will pull it out. Now this triangle is an equilateral triangle because each side is 8 units, which you can see it is equilateral, or I can move this a little bit to make it clear. You can see nearly it looks like an equilateral triangle now. So the sides are 8, 8 and 8. B being the midpoint, the distance between B and R is 4. Now the first thing, I'm going to find the distance between Q and R. We have to establish what kind of right triangle is this, and I can see it. This angle is a perpendicular because if a point like point Q is equidistant from the end point of a line segment, which is BR, then the point Q lies on its perpendicular bisector. So this QB is a median of this triangle, as well as because it is equilateral, so this angle QBR is a 90-degree triangle. This angle, which is PRQ, is 60 degree, and the third angle of this special right triangle is 30 degree. We might justify using two different arguments. One, because QB is a median which divides this, and it is an equilateral triangle which divides the angle which is 60 degree into two halves. So this is 30 degree. The other argument, if the one angle is 90 degree of this triangle QBR, then the third angle has to be 30 degrees. So this is the special right triangle, which is 30, 60, 90. the smallest leg of this triangle is BR, which is 4, and QR is the longest, which is the hypotenuse. So QB, the second leg, is going to be 4 square root 3 because it is a special right triangle. So QB is going to be 4 square root 3, which is also written in here. So let me write it that this one. So this side QB is going to be equal to 4 square root 3. That is the median. So that will be the length of BQ. Now the next thing is I'm going to find the other side. Let me readjust the figure back to this one. So now we found QB, which is 4 square root 3. We are going to find the next step. I'm going to find how much is SB. So let us find the SB. Now you can see I'm drawing this. Then this is another triangle. I pull it out. This triangle is also an equilateral triangle, and using the previous argument for this triangle, we can say the SB is also going to be 4 square root 3 because SBR is also an 30, 60, 90 degree triangle. Let me see if I can make the visual. You can see it now that yes, it looks like an equilateral triangle, and angle SBR is 90 degree with the same argument as we discussed before. So this triangle is also a triangle. SBR is also a 30, 60, 90 degree. So SB is going to be 4 square root 3. So now I'm going to go back to the position where we can see the whole the solid. Now we get this. Now so we got the two sides. One side, this side is 4 square root 3, and this one is also 4 square root 3. Now we have this triangle, which is BQS, and we are going to work on this triangle to find the value or the measure of segment AB. So let us try and use the third triangle. So I'm going to this is my final step to find the answer. As you can see, this QB is 4 square root 3 and SB is 4 square root 3. This triangle BQS is an isosceles triangle and it is not equilateral. The reason is that QS is this length is 8, and QB we found earlier is 4 square root 3, and SB is 4 square root 3. So these two sides are same, so it is an isosceles triangle, and BS is the median because it is connecting to the midpoint. Triangle BAS is a right triangle because this angle is a right angle. Why it is a right angle? Because again, point B, if a point is equidistant from the two endpoints of a line segment, then the point lies on its perpendicular bisector. So BA is also a perpendicular bisector, and this angle is 90 degree. So this is 90 degree. So now I'm going to use triangle BAS, which is a right angle triangle whose hypotenuse is 4 square root 3, and the other leg, one of the leg is 4 because A is the midpoint, so this is 4. Now the other leg, which is AB, we can use the Pythagorean theorem, like A square plus B square equal to C square, which is the Pythagorean theorem. In here, C is given as 4 square root 3. We'll find the square of this, and A is given as, let us say, 4 square, and B, I have to find it, so B square. So B square is going to be equal to 4 square root 3 quantity square minus 4 square, and then we'll take the square of this one, which is going to be 48, and this is 16. So B square equal to 32, and when we take the square root of this, so therefore B we get as 4 square root 2. So the value of AB is going to be 4 square root 2, and the answer is A. I hope you understand the entire explanation. This is a hard question.